Okay, we're going to go ahead and analyze this rational function. The first thing I would do is we need to factor this out on the numerator. We'll go ahead and leave the bottom alone, x plus 3. And it's an easy one to factor because we have a leading coefficient of 1. The first terms that multiply together give me x squared are x and x. I noticed that my signs here have to be different in order to produce a negative 10, so we'll go plus minus. And I'm looking for numbers that multiply to 10 and add or subtract. And in this scenario, it's subtract to 3. And it's 5 and 2. Now, since this is a negative 3, I'm going to put the larger number with the negative, 5 and 2. And we'll do a quick check here. My inners would give me 2x. My outers would give me negative 5x. And those would combine to give me negative 3. Okay, the first thing I do, x-intercepts, are what values could I plug in for x that would produce a y value of 0? And what we're looking for is zeros in the numerator. And a negative 2 in that first set of parentheses here would produce a 0. I'm going to write it as a coordinate point. And in the second set of parentheses in the numerator, a positive 5 would create a 0 in the numerator. And a little side note here, we do know if I have 0 divided by any number, like this, it would always produce 0. So I don't really care what's in the denominator or what else is with that 0 up above, as long as I create 1, 0. Okay, I'm going to go ahead and plot these points, negative 2 and positive 5. The y-intercept is what y value would I get if I plugged in a 0 value for x. And I always like to look at the original, 0, 0, 0, and I would get negative 10 left over on the top and positive 3 on the bottom. I'll go ahead and plot this point. That's negative 3 and 1/3 roughly, so about right there. Okay, vertical asymptotes. What would create a 0 in the denominator? And in this denominator, it's x equals negative 3. Now, often people will say, I thought we couldn't have negative 3 for an x value. This is true. But what that x equals negative 3 is, that is the equation for this vertical line right here that the math can never cross, called a vertical asymptote. Okay, before we do all the limit and end behaviors and domain and continuity and symmetry and boundness and whatnot, we're going to look at horizontal and slant asymptote. Now, if I look back at my original polynomial, okay, this is x squared over x. I just look at the leading variable, and this is a scenario where it is a top bigger. So there is no horizontal asymptote, but that means there is going to be slant asymptote. And I'm going to go ahead and do this work over here. I'm on the left. I get x squared minus 3x minus 10. We're going to go x squared minus 3x minus 10. All of this divided by x plus 3. And we're going to do some polynomial long division. When I do polynomial long division, my goal is to turn this leading variable into this leading variable. And I do that by multiplying it by x. Now, it's a lot like distributing. I have to multiply that x by x and this 3 by x. And I get x squared, and I get a positive 3x. I put a line underneath it, and I need to subtract this whole line. And the way I do that is by changing both signs, negative and negative. This goes away. I get negative 6x minus 10. And again, what do I multiply that x by to turn it into negative 6x? And the answer is negative 6. A lot like distributing, here and here, they both have to be multiplied by negative 6. I get negative 6x minus 18. Put a line underneath it. This is an important step. Change both signs. And I get a remainder of 8, which I could care less about. This does nothing for me. This is what I need. So my slant asymptote is y equals x minus 6. All right, that is a linear equation with a y-intercept of negative 6. And then I'm going to rise 1, run 1. Right here, boom, boom, You'll notice it also crosses at positive 6 there. So we'll go ahead and connect these dots. I'll extend it to the left here. And there's my slant asymptote. Now, before I graph this thing, I'm going to go ahead and cheat and use my calculator here. You'll notice I already typed it into y equals. And I also changed my window so it matches with the window in this particular problem. And you'll notice that I have a y minimum of negative 20, because down here at the bottom of my graph, my y goes down to negative 20, and everything else looks great. I hit graph. You get something that looks like this. Another nice thing I can do here is I can check my slant asymptote to make sure it's correct. X minus 6, hit graph, and it follows my curve perfectly. Okay, so we'll pull this off for notes purposes. Yeah, that's a good spot for it. Actually, I'm going to move it over here, and I'm going to shrink it up a little bit. There we go. Okay, we'll go ahead and sketch a graph. So I need something that starts up here, goes through the red, the green, through the red, follows the asymptote. And then I'm going to have something that's similar down here. So it will come up this way, go down like this. Okay, and I'm not super picky about the points down below as long as I have the general shape, but I should notice that those are roughly the same distance from that crossing of asymptotes there. Okay, let's talk about the behavior of this as it approaches the vertical asymptote. So I'm going to approach negative 3 from the negative direction and negative 3 from the positive direction. So I'm going to go ahead and highlight my finger over my graph. As I'm coming from the negative direction and I'm approaching that blue line, I notice the closer I get to it, my y value should be going down forever. So my answer here is my y values are approaching negative infinity. Likewise, as I approach the blue line from the positive direction, the closer I get, you'll notice my y values keep going up and up and up forever. So that would be positive infinity. My domain and continuity kind of go together. This is a continuous graph except at one point. I would say continuous except x cannot equal negative 3. And that's where I have that vertical asymptote. And this comes into play with my domain written in interval notation. I could go to negative infinity direction forever. I'm going to get real close to negative 3. I can't touch it, but I can get close. Union. And then I'd pick back up at negative 3 and go in the positive direction forever. Symmetry. We usually go with odd, even, or neither. Even means I could reflect it over the y-axis. Odd means I could rotate 180 degrees. This is a neither situation. Boundedness, it's not bounded above, it's not bounded below. So I would say none. And then last but not least, our end behavior. A lot like approaching the vertical asymptotes. This time, I'm going way out towards the negative direction. You'll notice down here it says I'm approaching negative infinity. So the farther I get out here, you notice my y values would keep going downhill. So my answer here is negative infinity. And if I'm approaching the end of my graph, going out towards positive infinity, the farther I get out here, okay, I would follow that slant asymptote, which just keeps going up and up and up. So that means my y values would approach positive infinity.